Hey guys, today we're going to do proportional relationships with graphs. So we're going to look at the very top here. It says Isabel walks to work each morning. It takes her 5 minutes to travel one city block. Use this information to complete A through B. A says to sketch a graph to show the number of blocks Isabel can travel in a specific amount of time. Well, what's important to know is it tells us it takes her 5 minutes to walk one city block. So I'm going to look at my table and pay attention to my x and y axis. So the x-axis is the one that goes left to right, and the y-axis is the one that goes up and down. So it takes her 5 minutes to walk one city block. So I'm going to go starting at the origin here. I'm going to go to the right 5 minutes and then up one city block. And then if I think to myself, well, if she walks 10 minutes, she should walk 2 city blocks. And then if she keeps walking at that rate, she should be basically increasing at a constant rate. So I'm going to connect those dots, draw my line, do my best prediction here. Part B. What features of the graph help you determine if the relationship is proportional? Well, it goes through the origin, so we're going to put that. Goes through origin, and then increases at a constant rate. So increases at constant rate. All right. So that's basically what we're going to be focusing on today. Proportional graphs. The line always passes through the origin, which is located at 0, 0. That's the center of the graph. The rate of change will always be equal to the constant of proportionality, which is represented by the letter K. And then our equation of the line will always be y equals kx, where k represents that rate of change. Example, it says to use the formula k equals y over x to determine the rate of change. So if we look at this graph, we have to pick a coordinate. We have 1, 1, 2, 2, 3, 3, and even backwards we could use those. So k equals y over x. I'm going to write the ordered pair down below here. I'm going to pick 2, 2. So the first number in our ordered pair represents the x values, and then the second one represents the y values. So the y is 2, and the x is 2. 2 divided by 2 is 1. So the rate of change is 1. All right, 1 through 2, we have to find the rate of change, but first we have to graph. So let's take a look at the word problem. It says an ATV travels 25 miles each hour, where x is the number of hours and y is the total miles. So it's important to know what your x and y are if your graph is not labeled, because you have to label it. So x is hours. I'm going to write hours on my x-axis. Remember, x values are the ones that go left to right, and then y values go up and down. So on my y-axis, I'm just going to write miles. Okay, so it says an ATV travels 25 miles each hour. So at 1 hour, they should travel 25. And then if they're continuing at that constant rate, 2 hours should be 50, 3 hours should be 25, 4 should be 100. And then you just connect your dots, draw your line, do your best guess here. Now the rate of change. Well, what were we increasing by each hour? 25. And then our equation, y equals 25x. It's whatever we're increasing by constantly. Number 2, the number of cars, x, so number of cars, x, is proportional to the number of wheels, y. So I'm going to put on my x-axis number of cars, because that's what it said. And then for my y-axis, I'm going to put number of wheels. So it doesn't tell us much, but we've all seen cars before. So let's think to ourselves. A car has 4 wheels. Sometimes it has a spare, but we're not going to include that in this. So a car has 4 wheels. And so what I'm going to do is I'm going to look at one car. So I'm going to go to the right one. One car has 4 wheels. Well, then if I'm looking at 2 cars should have 8 wheels. And then 3 cars, so 3 times 4 would be 12. And I feel like that's enough. So I'm going to connect those dots, draw my line, and make my best guess here. Now the rate of change. Rate of change, remember, is our constant of proportionality, which is y over x. So I'm just going to pick an ordered pair here. And the ordered pair that I'm going to pick is 1, 4. So 1 represents the x values and 4 represents the y values. So it's going to be 4 over 1, which equals 4. So then our equation, y equals 4x. Okay, we're not going to do this last one, so flip your paper over. Number 4, it says to use the information in the table to complete the graph and answer the questions. So looking at our table here, number of boxes is our x values and number of bandages is our y values. So I need to label my graph first, with our x values being number of boxes. So I'm going to put number of boxes and x, and then y is the one that goes up and down. So then my y values is going to be number of band-aids or bandages, whatever you want to write. And we're going to plot. We're just going to do our best guess here because our increments aren't quite exact with what's going on in the table. So if we look at 2 boxes, there should be 24 bandages. So I'm going to go to the right 2 and then up to 24, which is just a little bit not quite in the center between 20 and 30. It's just a little bit below. And then the next one is going to be 3 boxes at 36. So that's going to be just a little bit above. And then that next coordinate is going to be 5 and 60. So I'm going to go to the right 5 and then up to 60. And then I'm just going to stop plotting there. I'm going to connect my dots, draw my line, make my best guess here. So it looks something like that. Now we need to determine the rate of change. Well, the rate of change equals y over x, which equals, and I'm just going to pick the first ordered pair. So I'm going to do 24 over 2, which equals 12. So the rate of change is 12. Now for the equation, y equals 12x. Number 5. A farmer is plowing his cornfields. The relationship between x, the hours driving the plow, and y, the number of rows of corn plowed, is shown in the graph at the right. Part A. What does the point 0, 0 represent? Well, besides it obviously being the origin, in the context of the problem, 0 hours means 0 number of rows of corn, which means he hasn't started. Part B, choose an ordered pair to find the constant of proportionality. So remember, we got to find a spot where the line crosses in a corner perfectly. And I see right here at 4 and 60, that's a spot right there. So I'm going to write that ordered pair, 4, 60. Now to find the constant of proportionality, remember it's k equals y over x. So it's going to be 60 over 4, which equals 15. Part C, write an equation to represent the situation. Well, the constant proportionality is 15, which is also the rate of change. So it's y equals 15x. Number 6, Patricia is asked to determine if the statements below represent the graph. Check all that apply. So looking at this graph, time, which is the hours, is our x-axis, and then the cost in dollars is our y-axis. So the first statement says the equation y equals 2.5x represents the situation. Well, I need to determine the rate of change to see if that's true or not. So I'm going to find a spot where the line crosses through a corner perfectly. I see right here it crosses at 2 and 5. So I'm going to write that order pair, 2, 5. And 2 represents the x values, 5 represents the y values. So I have to set up my ratio as 5 over 2, which equals 2.5. So yes, that is a true statement, because if we write the equation, it's y equals 2.5x. I'm going to look at this statement down below. It says the cost of parking for 8 hours is $20. So I'm going to go look at that table, or the graph, I should say. I'm going to go to 8 hours, and I'm going to go up, and I see that it crosses at $20. So that is a true statement. The next one, it says the cost for 10 hours of parking is $4. So looking at the graph, I can't go to 10 hours, but what I can do is I can look at the cost, which it said the cost for 10 hours of parking is $4. So if I look kind of down a little bit below 5, it would not be 4 hours. It would be less than 2 hours. So that one is not a true statement. And then it says the graph will contain the coordinate 12, 30. Well, we can figure this out by dividing. So remember, the first coordinate is our x value and the second coordinate is our y value. So it's k equals y over x. So I just have to divide. So I'm going to do 30 over 12. So 30 goes in the house, 12 goes on the outside, and I'm going to start dividing. So 3 is obviously too small. 30 is bigger than 12, so I have 12, 24, 36. 36 is too big, so it goes in 2 times, minus 24, for a remainder of 6. I'm going to add a decimal in my quotient as well, bring it down, so it's 60. Well, I have 12, 24, 36, 48, 60. So it goes in 5 times. And if I subtract 60, I have a remainder of 0. So yes, that is also a true statement. All right, good job on solving problems involving proportional relationships with graphs.